Okay. Good morning, guys. So today our topic would be on file formats and some of the important points to understand when we are talking about file formats. We'll get started with understanding what is a row-based file format and column-based file format. Okay, and we'll try to see how they are different, which one is better, which one should be used in which scenarios, and then we'll get started with discussing about each of the file formats like CSV, JSON, Avro, Parquet, and ORC in stretch. When I say in stretch, we will deep dive into their architectures and how data is maintained within those file formats and which one is better for big data and why. Okay, and we will try to cover the source data types at the end of towards the end of this session that we can talk about API and JSONs and tables, flat files, all these uh, types of data formats that we'll receive. But our focus will be on understanding how a data is stored in both column and row, and then how each of these files are going to store the data. Okay. So last week we discussed about the types of data we have, like structured, unstructured, and semi-structured. So continuing with where we left off, we'll get started with the column-based and row-based file formats. Okay. So if you look at this example, I have prepared this example to elaborate on the row-based format. So this is the row-based example that you are seeing actually. So what happens in row-based format is if you understand, if you try to understand how data is written to hard disk. Okay, we have hard disk storage, right? So whenever data is being written, what it does is it is going to look at the data and it is going to divide that data into blocks. Okay, so each block could be somewhere between 4 KB. That's the standard, but it could be more also. Okay, so generally it will be 4 KB each block. So what happens is when we are writing this information, let's say, we have data in column B, C for until row 6. Okay, so this is our data that we want to write it to disk. So when we are trying to write this data to disk, what happens is it is going to write this data in blocks. So if we are writing it into a row-based file format, what happens is in each block, it is going to store the row information sequentially. So it is going to write the data horizontally. So as you can see in block 1, it is writing data like this. First, it will write the entire data of Suresh for all the columns, and then it is going to write the data of Ramesh for all the columns. And then, I mean, here I am just assuming that each block is going to write only two rows. Okay, but in general, depending on the data, depending on the size, it will continue writing the data on block until unless it reaches that 4 KB limit. Okay. Similarly, in block 2, it is going to write the data for Raghu and Raju. Okay. Even if we have more number of columns, the data is going to be written in the same format. Okay, guys. So this is how data will be written if we are using row-based formats. Okay. Now, on this data that we have written, let's say we are trying to perform some query. We want to write some query to analyze this data that is being written on a row-based format in the disk. So here what we are trying to do is assuming data is our table name or file name. We are just doing a select star from data. So in case if you are not versed with SQL, select star from data means select all the columns. Star means all the columns from this data table. Where means the filtering clause. Name column must be one of Suresh or Raghu. Okay, in means it is going to filter a list of values. It is going to look at a list of values. So where name is Suresh or Raghu, then only you give me data for name, salary, and department. This is what the query means. Okay, star means it is going to select all the columns. only when the name is Suresh or Raghu. Okay. So if you look at this output here, what we are trying to do is what this query is going to do is it is going to read block one because this is stored in row based, right? So what it is going to do, it is going to read the entire block and it is going to bring this data from this block, Suresh, 50,000 and HR. Okay. And then it is going to place it in the output. Then in the block 2, it will look at Raghu and because data is written in the row wise, it is going to fetch this block and it is going to display it in the output. So once it combines both and it is going to display the output to the user, right? This is fine because we are doing a select star from data. So we are selecting all the columns. So it is going to fetch the data from the disk as it is. Let's say we are not looking at all the columns. What we are trying to do is we are trying to filter the columns here. We don't want to get all the columns. We want to get only limited columns like name and salary. So what happens here? Yeah, Amita.
Yeah, hello sir. Today I have joined and this is my first class. So currently you are teaching SQL today?
No, no, we are talking about file formats.
Okay, file formats. Okay, so what will be the sequence of teaching? Initially, what you will start?
We have course curriculum in the website. I can share it to you. So what we are trying to do is we are trying to get started with the data engineering fundamentals, and
Hmm.
we'll start with the data fundamentals like database, data lake, data lake
Hmm.
house, and all. Then we will start with Azure fundamentals, and once we are
Okay.
done with all of these fundamentals, we'll get started with Azure services for data
Okay.
engineering.
Okay. Okay, sir. Thank you.
Yeah. So here, if you see, for now, what we are trying to do is we are trying to filter only on name and salary. We don't want department. So we want to skip the department column here. So what happens here when we write this query is it is going to again read all the blocks, guys, because the data is stored sequentially, right? So you cannot skip this department at all. You have to go through this entire row information because it is written in rows. So even here, even when we want Suresh and 50,000, we don't want HR. But unfortunately, data is written here in the sequential manner. We will have to read this entire block again for Suresh. And we will have to fetch only Suresh and 50,000 at a later point of time when we are displaying the output. Okay, so the problem here that I want to highlight is that if you have, let's say, 20 columns, guys, so 20 column data is stored sequentially, one beside another, right? So this is the problem in the row-based formats where you cannot skip certain columns when you are trying to access only few columns from the entire data. So if you have 20 columns and if you want to access only two or three columns from the 20 columns, you cannot skip those remaining 18 columns because data itself is written in that manner in the disk. So this is a performance overhead on any data set, right? If you are talking about big data like 10 GB or 100 GB, it is a performance overhead because the the compute engine that it's trying to access data is reading everything. Even though we don't want those columns, it is reading those columns, right? This is the performance overhead for row-based formats, guys. Okay. Any questions still here? Okay. I'm assuming no. So yeah. So what happens is the overall summary for this row-based formats is you cannot do a column-based skipping, okay, or a block-based skipping because you don't know which block is going to have which data, right? So you cannot do a skip of any column while reading the data, or you cannot skip any block while reading the data. You will have to go through every single block and every single column. Even if you don't need it, you have to do it. That's the limitation. That's the biggest disadvantage of using row-based formats. Okay. We will talk about when to use this, but that's the biggest disadvantage for us. Let's move to column-based format, guys. So this is the column-based format. We have the same information here, but what happens now? when we are trying to write data on disk, let's say we are using column-based file formats. Okay, so what we are trying to do is we are trying to write this information in disk. What happens now is it is going to write whole column data in a block, guys. So if you see, name column is written in block one. Okay, then it is going to write salary column in another block. Okay, this is the basic example. In the industry, when you are trying to write so much of information, there is high chance that this block 2 data is also written in block 1, because block 1 size is big. So what happens is this may come like this. But what happens is it is going to do vertical writing, guys. So it is going to complete the name for limited information, and then only it is going to write the next column data. So the column data is stored in groups, in sequence. Okay, so this is a possibility, but for the example, I'm just telling you that this is how it is written. Okay, so in the block, it is going to contain name. In the block 2, it is going to contain salary. In the block 3, it is going to contain the department. Okay, so what happens now is when you write a select star from data on top of this data, it is going to read all blocks again. Why? Because you need data for name, salary, and department. You need data for all the columns. You are not skipping anything. So obviously it is going to read all the blocks. Okay, that's first thing. Then second thing is it is also not going to know which column data is available in which block, because you are doing a select star. So it is going to read all the blocks again. So the answer is that the point here is if you do a select star from any table, or if you are trying to access the whole column information from any table, there is no difference between row based and column based, because you are accessing all the columns. So there is no difference between row based and column based when you access all the columns from the data. Okay, please note this. And the difference comes when you are trying to access only limited columns or only required columns, guys. So this is where column format is going to overperform on top of row based, because if you see, it is only selecting name and salary. This is same query which you have just shown in row based. So here if you see, it is looking at only name column and salary column, right? So what it does is it is going to read block 1 for name and block 2 for salary. It is going to completely skip the block 3, because it is clear that block 3 is going to contain this department information. So while doing this read operation, what it does is it is going to skip entire block 3 and it is going to display only block 1 and block 2 data. Okay, so this is going to improve performance of reading the data, correct? Because we are completely skipping an entire block. So this is the advantage of using column-based file formats for reading the data. Okay. Any questions?
Yeah, one question. How does it relates block one with block two? Is there any ID in between?
Yes. We are going to talk about how this block one and block two understands which data is stored within them. It is a much more detailed thing that we'll cover when we are talking about the Avro, Parquet, and ORC.
Okay,
That's a good question. That we are going to see in couple of minutes.
sure.
Yeah. So that's the advantage of using column-based formats, guys. It is going to completely wipe off a block depending on the columns that we are selecting. So if we are selecting 20 columns out of 30 columns or 40 columns, it is going to exclude those 30, 40 column data in seconds. Okay, that is the biggest advantage. So because we are talking about row based and column based, I have a question for you guys. Um, After looking at these two examples, we are currently in a position that column based is the best. Now you tell me, when can we use row based formats, guys? When is this option preferred? Can you guess in
And
which?
when you need a less columns information, then a column based is good. Suppose if you are querying a more number of columns then we need a row-based information.
Okay. Well, okay, that's one answer. Let's also look at if there is any other perspective from anyone else. When do you think a row based is more preferable over column based? In which scenarios? So let me give you some hint. We have two operations on any data that we do, right? One is read operation, one is write operation. So
Yeah,
split into
when you're going with read operations, then columns to the column block is useful, and when you go with write operations, maybe you go with row ones.
yes. Why? Because when you are writing the data to a file, it is easy if you are going with row wise, because you will write entire row in one single transaction, correct?
Yes.
When you are writing the data, row based is the best format. When you are reading
Yeah.
the data, column based is the best format, because you have already written the data, you are just reading it. So column based are preferred when the operation is read heavy. That means you want to read the data. Okay.
Yeah.
And generally, in which scenarios we are going to read it, guys? When in which scenarios, if you think about the availability of databases, we have two. One is OLTP and one is OLAP, right?
OLAP.
So OLTP is generally used for write heavy. It is going,
Transactions. Yeah.
yeah, it is going to write much more data than it is going to read. So OLAP is going to have a read heavy operations and OLTP is going to have write heavy operations. So we'll talk about this too in detail. But for now, assume this as a database, and this is a data warehouse, which means that this is frequently updated. This is a database is nothing but a storage system which is frequently updated on a daily basis. Warehouse is nothing but it is going to store historical data like previous past information. So okay, so write heavy means it is going to perform insert, update,
Updates,
delete,
deletes.
merge, all these operations on regular basis. Okay, so whenever you are trying to write the data and trying to use one of these operations, then row based is suitable. Okay. When you are doing a select star or select statements, then column based is suitable. Okay. So this is the basic idea of when a row based is should be considered and when a column based should be considered. So if you are trying to write more data, then go with row based formats. If you are going to do a read, you have to pick the column based file formats. Now we will try to connect this to our data engineering stuff. If you think about this, uh, initially we know that we have a source, we have a destination, right? That's a common in data engineering pipelines. So at the source there is a high chance that it is going to be a write heavy services. Okay, at the destination it is going to be read heavy services. Okay, that means anybody who is going to uh, build a data pipeline, at the destination of that pipeline, they are going to allow other roles to read this data. If you remember in our initial sessions, we talked about data analyst, BI developer who is going to read our gold layer data, right? So that is where we are going to use this column based formats, guys. That means any role who is going to read the output of our pipelines. Okay, if you remember, there was a screenshot where I have shown how data engineering extracts multiple sources and then builds a pipeline, and then he's going to give this gold layer output to some of the data analysts and BI developers, right? So try to relate that screenshot, that uh, topic here. So when we build a pipeline, we may read data from write heavy services. So what we will do is we will create a row-based file formats. When we are giving this data to any other role, like let's say data analyst or scientist or BI developer, when we have transformed this data, when we are loading this data, it is going to be a column-based format, guys. Okay, so this is how I want you to relate uh, about why row-based is better, why column-based is better. So in our pipelines, when we are extracting data, preferably it will be in row-based formats. When we are storing the data, when we are giving the data to our stakeholders, it will be in read-heavy formats, okay, which is more of a column-based file formats. Okay. Let me just clear this. Okay. I have some screenshots here just to give you the context, just to um, ensure you are understanding this. Here, if you see the row-wise format, you have these many rows and it is writing row by row, right? It is going to write row by row. As you can see, A0, B0, C0 is written sequentially. So this is horizontal partitioning, and like we discussed, it is going to be used for write-heavy operations whenever data is written frequently, more frequently than reading. Similarly, if you look at columnar file formats, it is vertical. If you look, though it is highlighting row, but if you see the file data is written like this. Yeah, Deepak.
If you could go to the other slide of row based.
Okay.
When do you think it will decide to break at A to B to C2, and then it has to move to next line here in this case?
Yeah, good
What's the
question.
condition for that?
Yeah, good question. If you recall, we discussed about block size, right? So until unless it meets that block size, it is going to write. So if the block size is 4 KB, so it is going to write data till 4 KB and then only it is going to move to the next.
Okay.
Okay, so blocks, I mean, irrespective of row wise or column wise, data is written into blocks only, and each block is going to have a fixed size, and it is going to be same for all blocks.
Okay.
Okay?
So it is not decided by the system. It is given by us, is it?
No, it is decided by system only. It is 4 KB. From what I remember, it is 4 KB. I need to do a research on what is the fixed size. From what I remember, it is 4 KB and it is fixed. It will increase the number of blocks. That's it. Size is fixed. If the data is more, number of blocks will be more.
Okay.
Yeah, good question, by the way. Okay. So columnar, like we are seeing, it is vertical partitioning and it is going to write it in column-based order. So the whole A column was written first and then whole B column was written first and then whole C column was written first. So the disadvantage here is that if you want to access entire row, like Yogi said, if you want to access entire row, then this would be a problem, right? A0 is stored somewhere, B0 is stored somewhere, C0 is stored somewhere. So this is not a great example of accessing entire row. So this is for OLAP. We can talk about projection, push down, and compression opportunities as we move ahead with the course. Now we have understood row wise, we have understood column wise. But what if we need the advantage of both? Okay, so let's say I want to have a row wise format as well as column based format because I don't want to lose the advantage of both these systems. I cannot decide between row wise or column wise, right? So to solve this problem, there are some new file formats created called hybrid. Okay. I think I should have it.
So in the meanwhile, you're pulling that this one. So in general, in the SQL Server, the default size is 8 KB. So whatever the data is stored in the KB wise, like in the page, one page size is block size is 8 KB. So and an extent size is called 64 KB.
Yes.
So it will store in extent wise, and in the database on each table, suppose you have a column A, column B, column C, it is a table. So for each table you can create an indexes. So indexes will create a pointers to each data, and it knows like which data is stored in the which pages, and those blocks will bring whenever you are querying a data. Yeah, but here, like, I don't know about the 4 KB, like maybe it is a different databases, but in the SQL, it will be 8 KB pages.
Yeah, so I just wrote a query. I mean that is not for SQL tables. This is
Okay.
for file formats only. Like let's say you are writing a query on top of a file. That's what I'm trying to say.
Yeah, yeah, I
And
got you. I got you.
yeah, and
Mhm.
also you may get a doubt that can we query a file? You can absolutely query a file, and we will see it in the future sessions as to how you can query a particular file. This is the biggest, uh, biggest the advantage of the big data and something called as Delta Lake, which we have in our
Mhm.
scope. So within Delta Lake, you will be able to query the files, actual files, CSV file, JSON files, and we will see all of this in the future sessions. For now, we will also talk about the indexes and all as we discuss about these file formats. We have indexes in ORC and Parquet. We'll talk about that in a moment. Thank you for bringing that. Let's see about hybrid, guys. So the solution is to have a combination of both row based and column based. Okay, because we may need to have advantage of both together. So what they have done is they have brought up a solution to have both row based advantages and column based advantages in a single file formats. So what this hybrid format is all about is it is going to store the row-wise data in uh, something called as row groups. Okay, so what it is going to do is it is going to create a row group first. Row group means a group of row level data. Okay, let's say here if you see A0 to C2 is a row group. Okay, within this row group, it is going to store column level data. Okay, so it is going to look at A0, A1, A2, B0, B1, B2, C0, C1, C2 as in this example. Okay, and this is completely decided by the file format itself in the backend. We have some configurations in place, but that would be too deep for us to go through. Okay, but for now, I want you to understand that this hybrid format exists and it is going to have row groups. Within row groups can range from 1 to n, and within those row groups, the chunk of a column, it's not a complete column data, the chunk of a column data is stored. Okay, like you see here, A0, A1, A2, B0, B1, B2. Okay, now what happens is within this column chunk and row group, there is also something called as metadata. Okay, we'll talk about this metadata. What is metadata? Metadata is data about data, which means whatever data you are storing in row group, that is going to be highlighted in a metadata layer. So within metadata, it will contain, okay, row group has this information. Okay. Similarly, it is going to store the column level metadata also. What is the minimum value that is being stored here? What is the maximum value? Okay. So let's take one example. So let's say instead of A0, A1, A2, we have 1, 2, 3, 4, 5, 6, 7. Okay. So what it does is when it is going to store this column level data, it is going to store the minimum of this column chunk. What is the minimum of this column chunk? If we assume 1, 2, 3, it is 1. So A0 is replaced by 1 here. So the minimum value of this is 1. The maximum value is 3. Okay. So in the metadata layer, for each column chunk within each row group, it is going to store minimum, maximum, count like this. It is going to store all the statistics. We will see it. I'm just explaining you verbally. we are, it is going to store it in that way. So somebody asked me a few minutes ago how it is going to know which block contains which information and all. Based on the statistics that we are talking about just now, based on the minimum value, maximum value, it is going to identify whether I need to read this column chunk or not. So let's say you are trying to access column A when the column A value is 5. Okay. So here if you see 1, 2, 3, 4, 5, it is in A4. So A4 is in row group 2 and column chunk 1, 2, 3, 4. Right. So what this tool does is whatever, so if you are using Spark or if you are using any other software computing engine, what it does is it is going to look at minimum and maximum value of this, and it is going to start skipping. If there is no value for, if you look at this, column A stores in only this column chunk 1 and column chunk 4. It is going to skip all the remaining column chunks. Okay. What it will do, it will just come here in A0, A1, A2 chunk. It is going to look at minimum value, maximum value, and it is going to assume that, okay, this block is not having our required data. It is going to skip this. It will come here in the next column chunk. It will look at A3, A4, A5. I mean, let's say it is 4, 5, 6. So it is going to just pick this block and it is going to see what is the minimum and maximum value. Here minimum value is 4, maximum value is 6. We want 5, which exists in this. So it is going to pick this block. That's it. Okay. So this is how it is going to give us an advantage of both row based and column based, and it is going to skip the blocks. Okay. So the vertical partitioning and horizontal partitioning both exist. Why do we have horizontal partitioning? Because let's say we want to write this data. Still we need rows, right? Rows are the better formats for writing data. So in case if we want to write data, we don't want to lose the advantage of row based format. So that's why it is, these file formats are having this structure of storing the data in column chunks. However, while writing the data, it is going to be written in row groups. Okay, all of this is done internally, guys. We need not have anything to do. We'll not even see how it is written, because these file formats, whichever we are going to talk about, are binary file formats, which means it will be also serialized into some binary formats, some zeros and ones. You'll not even get to see string or integers or anything as such. Okay. It is going to serialize and deserialize whenever we are going to access the data. Okay. Um, let us look at some of the okay, this is Parquet. Yeah. Let's get started with this file formats real quick, and then we'll go ahead with the Parquet, because Parquet, Avro, and ORC are the industry formats that we are looking at today. We also have few like Delta tables, Apache, Iceberg, and all, which we are going to talk about as we progress in our course when we talk about Databricks and how these tables are going to improve the performance of the existing file formats. But for today's class, because this is fundamentals, we are not touching these two. Okay. Let's start with CSV, guys. I think you are already aware of CSV. It's a comma separated file, basically, comma separated text file. That's a good way to define this. And generally, this file format is human readable, guys. So if you want to open it and if you want to see what is the data, you can always do. It stores, limited, or I would say small to medium level information. So this is not suitable if you have huge amount of data, like in GBs or in TBs, because this is going to crash, because this is human readable. it doesn't contain any binary formats, or it doesn't contain any optimization. File level optimization doesn't happen. So it is suitable only when you have medium level or small level of data sets. Okay, that is, I would prefer less than GBs. Okay, that's the disadvantage of having a CSV file. Um, Generally, the CSV files are used to share the data between two systems or two users. Okay, it is generally preferred to have CSV files if you want to share those data with two different people. So that's about CSV. Not much. We'll generally not look at CSV files at all in our projects also. But there is a possibility that while you are working on data pipelines, sometimes, once in 9 times or once out of 10 times, you may see CSV files as well in your storage system that you may need to convert it into one of these formats, Parquet or Avro or ORC. Okay. And I forgot to tell, this is row based, guys. So data is written in rows. Okay, and even it is accessed in rows. So this is about CSV. This is quick explanation about CSV. JSON, also we can JSON, if you see, this is a semi-structured. We talked about structured, semi-structured, and unstructured database. This is also human readable. Okay, and this can be sometimes structured in case, if you are maintaining the information for same number of values throughout the file, sometimes you can call it as structured. It contains some structure, but sometimes it is possible that it is completely structured. Okay, most of the times it is going to be used in APIs. Okay, so whenever we are trying to get data from APIs, most probably it would be in JSON. So that's about JSON, guys. It's not a big topic, but generally it is stored in key value pairs. Okay, which means you will either have a list, and within list you will have a list, and within list it will be arrays, or within arrays it will be a list of data. Okay, these are the only possibilities. So it will be in key value pairs like this. Um, that's something about JSON. We will not see much about JSON unless we work in something called Apache Kafka. So we'll talk about Kafka in a bit, and or I would say streaming data. Okay, cool. So we'll move to Avro, guys. So Avro is a row-based file formats. I wanted to spend more time on Avro, Parquet, and ORC because these are used in big data. CSV and JSON just as an introductory formats. We generally don't use much of them. So Avro is row-based and it is binary format, which means it is not human readable. Okay, you cannot read the data by opening the file. Okay, generally what it does is it is going to store data and schema in the file. So what happens is when we talk about Avro, we have this data, right? We have this data. If you see, this is our data. This is the schema, guys, for that data. Schema is we have name, which is string, and it is nullable. Nullable means it can store nulls. This just take this as an example. Okay. Then we have salary, which is integer, and it is nullable. Then we have department, which is string, and it is also nullable. Right? So this is the schema, guys. Schema of this table. Similarly, for each table, there is going to be schema. Schema means what is the column name, what is the data type, whether it is null or not. It contains null or not. Okay, or can you write nulls or not? While you are writing, adding data here, can this column contains blanks or not? Null means blanks. This is the schema. So when we are writing this when we are doing this operation, or if you are trying to write data to Avro, Immediately Avro builds a schema. Okay. If you are trying to write, then you have to define the schema. If you are trying to read, Avro already contains a schema. Okay. So what this schema is, so we discussed that data, I mean, we discussed about binary format, right? So data will be written in binary format. Schema will be written in JSON format. Okay. So when we are writing the data, we will give a JSON output to this schema, and data will be automatically converted into binary format. Now you may ask me, Ashok, we are writing this data. We are not writing data in binary, right? We are writing it in some structured manner. How come there is a binary format in the file? So there is something called serialization. Okay, so what this serialization does is, this is going to convert all of your strings, integers, and date times Boolean values into binary format, guys. Okay, when we are trying to read the data, it is going to automatically deserialize and it is going to give you the output. Okay, we may think about performance here, that okay, we are doing an extra step of serialization and then we are doing extra step of deserialization, but still Avro is super fast, because serialization and deserialization happens little bit in an optimized manner. Okay, it is not going to take a performance overhead. And the other advantage of Avro is, because this is going to store everything in a binary format, the file size is reduced, guys. We'll talk about this file size also. But what I mean by file size is, let's say within CSV, let's say you have a file of 100 GB. Okay. So within CSV, the file size would not change if you are writing it. Okay. So JSON, it may change, but let's also assume that it is 100 GB here also. What happens in Avro is, let me just get here. So what happens in Avro is, when you are trying to write this data will become somewhere around 60 GB. Okay, it is going to reduce the file size significantly because of this binary format. Okay, it is going to store everything as ones and zeros, so automatically your data size is reduced. So that is one of the advantages of using Avro based file formats. And the other most important item that we need to talk about Avro file format is, um, this is splittable. Okay, what is splittable? If you remember in our previous session on Friday, we discussed about partitions, right? We discussed about 10 GB file being split into 2.5 GB file for each computer. Okay. So splittable means a file can be divided into multiple blocks or multiple partitions. Okay, this is the meaning of splittable. You cannot divide this CSV into multiple partitions, guys. Okay, you can divide this Avro into multiple partitions, because what Avro does, if you remember, it does both data and schema in the file. So in each this partition, in each of this 2.5 GB partition, it is going to store data plus schema. This is how it is going to store. So because you have both column details and data within this partition, this is alone enough to access the data, right? It in CSV, if you divide, you will have to manually divide and you will have to give the column names, because column names are in within CSV. If you look at the data, it is going to store column names only on the first row of the file. Okay, if you divide the CSV into 2.5, 2.5, you will have to manually define the schema in each partition, right? So that is the biggest advantage of using these file formats, that they are splittable, which means they can be divided into multiple partitions, because they carry schema with them. Whenever they are written in multiple partitions, schema is also provided. So if you have to read this 2.5 GB alone, you can read it with no problems, because both data and schema are present here. Okay, so this is one of the biggest advantages of Avro. The other biggest advantage that we are going to talk a lot about in our future sessions is schema evolution, guys. Okay, so schema evolution means, let's say in your source data, you have 10 columns today. Okay, and you have read it in Avro. Okay, here also it will be 10 columns, correct? Now, tomorrow, the same source file became 12 columns in the source. Now, without need of creating a new file, Avro can automatically update itself to 12 columns, guys. Okay, you can use the same file. Okay, let's say this source data is abc table, some SQL table. Okay, and here Avro file is xyz.avro. So the advantage is, when your source data is being modified with new columns, or if let's say the 10 columns became 9 columns, okay, or if one of these columns have information changed, there is 10 columns only, but some of the columns information is updated. Avro captures everything. Okay, you need not update this information in a new file. Okay, so the schema evolution means the columns will get automatically updated. That's a inbuilt feature of Avro. Okay, and this happens dynamically. Okay, you need not even mention which columns are updated, which columns are old, which columns are dropped. You need not tell Avro about anything. It will dynamically auto adjust by looking at the source data. Okay, so these are the two biggest advantages of Avro, which is splittable and schema evolution. And like we discussed, splittable means it is going to allow us to divide it into partitions. And if you divide it into partitions, we already discussed in our previous class that it is going to allow you to do a parallel processing of data, right? So you can process your data on multiple partitions at the same time. Okay, so that is the biggest disadvantage. And this is row based. Okay, like we discussed. So this is mainly used in real-time processing. I forgot to say this. Majority of Kafka outputs are used in Avro formats only. We'll talk about real-time processing and Kafka, but for now, just assume that this is being used when the data is coming at a fast velocity, at a speed, right? So data is coming real quick in milliseconds, in nanoseconds, and Avro is best format to read that data. Okay. We'll talk about Kafka in detail in our future sessions when we are doing that project. But for now, you just understand that Kafka means, there are some data senders and data receivers. I don't know, sender is the right word, but let's just keep it. So, or let's say data producers. Okay. So what Kafka says is, if you are a producer, you publish your data whenever you want. And if you are a data receiver, you consume data whenever you want. Okay. So the producers can be, what they'll do is they'll send data uh, and they'll just ignore. Like what they'll do is they'll send the data and the data is stored in Kafka. Okay. So what this will do is this will allow parallel communication, guys, parallel and multi-consume communication, which means if there is single producer sending this data, and if this data is required by multiple receivers, all of these guys can look at this single information. Generally, what happens is if we have a producer one, and then if we have this data published, and we have three consumers, what happens is whenever this producer has to send the data without Kafka, let's say, he has to send the data to consumer 1, data to consumer 2, data to consumer 3. This will create redundancy, right? So what Kafka said is, instead of this, you publish data to Kafka, okay? And then all the consumers, let's say consumer want to access this data today, he will access. Consumer 2 is also going to access the same information whenever he want. Consumer 3 is also going to access same data whenever they want. These three will form a group called consumer group. Okay, this is all internal. This is done by Kafka itself. It will create the consumer groups, and all of these consumers are going to read the same data. Okay, this is a basic introduction. We'll look at a stretch, but the advantage of Kafka is that it is not. I mean, see, sometimes the data could be in CSV, data could be in Excel, data could be in JSON, right? So what Kafka says is, irrespective of your source, whatever your source is, you have to serialize it to a single format, binary format. Okay, doesn't matter what data is coming. Within Kafka, it is serialized. Okay, and before giving it to consumers, it is deserialized. This is the principle of Kafka. So Kafka says you have to serialize and then deserialize. Because there is serialized and deserialized involved, Avro is the best suitable format here. Because Avro does the same. If you remember, we discussed here. It is going to serialize and deserialize. So because Kafka uses this principle of serialization and deserialization, Avro works best for Kafka. Okay, and Kafka is also a real-time data solution, data processing solution. Because it is real-time data processing solution, Avro is preferred here within Kafka. It is
I
widely
have a
used.
quick
Mhm.
question about the Avro format. So you mentioned that data is in binary format and the schema is in JSON format. So, but this is let's say if I compare it with column and row based format, right? So for a particular let's say a particular data for let's say data that could be in a cell of a row and column based table format. So if I compare with that, how can two different formats of two different formats can exist in the same cell? So I of course I don't know anything about
Okay,
Avro, but I cannot visualize it.
understood. Good
Yeah.
question, actually. So this is about Kafka and how Avro is the best format for Kafka. To answer your question, see, it is going to read schema only once. Okay. So schema is stored at a footer. So within this file architecture, if you see, there is a schema that is written only once, and data is just packed with it. Okay. So if you look at this row based,
Okay, I see.
so this is, yeah. So if you look at Suresh 50,000 and HR, with this row itself, schema is packed. This entire schema. Okay, so how it stores is, let's say Suresh is like 1001. Just assume, this is something like 101010. So it is going to have a schema here. Similarly, for Ramesh, let's say it is 010101, something like. If this is the case, again schema will be present for each and every row. That's how it is going to write it into Avro. Okay.
Okay, I see. Okay, got it.
Okay, good
Thank
question.
you.
Yeah, no problem. Let's move with ORC, guys. ORC, we'll talk about Parquet in stretch. That's why I'm keeping at the end. So ORC is nothing but optimized row columnar format. So we talked about hybrid formats, right? So Parquet and ORC are hybrid formats. Okay. So these two are hybrid formats. The full form of ORC is optimized row columnar format. Okay, so this is going to be hybrid format. Okay, so this is preferably used to, this is also binary, but this is preferably used in Hadoop systems. We have something called Hive. Hive is nothing but a SQL warehousing system within Hadoop. Okay, so they use something called Hive SQL to write the queries on top of this Hive. Um, so this is preferably used when it is Hadoop. This stores the data in binary. So what this does is, I have architecture for ORC. Yeah, you see this? Yeah. So here, if you see what it does is, it is going to divide the whole data into columns, chunk of columns. That column chunk is called as stripe. You see stripe here, it is going to divide that entire data into column chunks, and all of those column chunks will be of 250 MB. This is the default size of ORC file structure. So 250 MB will be one column chunk, and here again there will be another column chunk like this. Okay, within that column chunk, it is going to write the row data. Somebody spoke about indexes, right? Just before that, in databases, we have indexes to look up. This is the index data, guys, in ORC. So this will also do the same. What it does is, it is going to store the information and the lookup values of where it is stored in this row data. Okay. Within this stripe footer means it is going to have metadata like the minimum value, maximum value, the count of the rows, number of rows, and some other statistical information about this column chunk. Okay. So this is how it is going to store the information. We generally don't use ORC in big data. We only use Parquet. This is just for your information that how ORC will maintain the data. Within the file footer, if you see, this file footer contains all of the metadata information about each of these column chunks. Let's say you have 3 column chunks here. The overall statistics of these 3 column chunks will be stored in the file footer. Okay, so this is how it is going to be a column based and row based hybrid model. So within each column stripe, it is going to store the row level information, and for that row level information, it is going to build an index. Okay, the metadata about row is stored in this footer. What is metadata? The minimum value of this entire row dump for each column. Okay, if you have 3 columns in this row, for each of the column, what is the minimum value? What is the maximum value? Okay, what is the count for that column? How many rows are there in that column? And some other internal statistics. Okay, it is going to store in the stripe footer for each of the column chunk. Okay, this is how ORC works in general. And the default is 250 MB, guys. Okay. The advantage of this ORC file structure is it supports something called ACID transactions. This is very important. We'll discuss in stretch when we are talking about Delta Lake tables. But ACID transaction means it gives you a guarantee that you are reading the correct information. Whenever you are reading it, it gives you a guarantee that you are not reading something old, something that has happened yesterday, right? It is a guarantee that you are reading the most current latest information. For now, you can just assume that ACID transaction means it is giving you a guarantee that you are reading the latest information. All right. So this is again suitable for read heavy. I missed this point. So read heavy means OLAP databases, which means anything, it is not preferred if you are trying to write the data frequently. It is preferred when you are reading the data frequently. Okay. Though it is a combination of row based and column based, still it is optimized for read-heavy operations. And like we discussed, it is predominantly used when it is Hive, when it is Hadoop. Generally, it is not used when it is Spark or when you are doing with big data. Okay. So the biggest advantage of ORC is its compression techniques. There is no single format that is matchable with this compression techniques that you have in ORC. Okay. So if your file size is 100 GB, this will compress that 100 GB to the best. Okay. So the compression techniques means there are some compression techniques like Snappy, gzip, bzip and all, which we will not use. I mean, like I said, this is only for theory purpose. We are not going to use it. Internally, it is going to do it. Okay. This is just for your information. So if you have a file, it is going to give you the best compression out of all these files. It even beats Parquet. We'll see that. But the compression is best within ORC. Okay. And like I said, it is efficient to work on Hive or Hadoop. This is not so efficient if you are working on anything other than Hive or Hadoop. This is tuned. This is tuned for Hive. Okay. Let's quickly see this. Okay. We'll talk about Parquet as well, and then we'll look at that. So Parquet is hybrid, guys, and this is also binary format. Okay. This also contains data plus schema. Okay. This is this is in same format. This is completely in binary format only. Then the serialization and deserialization doesn't happen. But yeah, file size is reduced. Okay, this will become somewhere around 25 GB, guys. Okay, this is splittable. This supports schema evolution. Okay. This is also used for read heavy operations in big data. All right. Yeah. So, this is most widely used file format, Apache Parquet, and this is also hybrid. Though people say it is columnar, it is still hybrid. Okay, and this is having a much better data skipping and data schema evolutions and data compression and encoding techniques when compared with Avro and ORC. Okay, so this is going to give you a let's say ORC is best in compression, Avro is best in storing the data with schema. Parquet gives you the advantage of both. Okay, and this is specifically tuned when you are working on Apache Spark. Okay, this is tuned for Hive. This is tuned for Kafka or streaming data. Okay, that is the reason you may hear with so many people that Parquet is used in, I mean, whenever they are talking about big data and Spark, they'll definitely talk about Parquet. They'll not talk about ORC or Avro or any other format because this, yeah, go ahead.
So is the Hive means like is it the Hadoop one format?
Yes, yes.
Okay.
So Parquet is predominantly used in the big data world because it is tuned specifically for Spark. Okay. And it is used for OLAP systems like we discussed. And what Parquet does is this is having some special features, the advanced features that no other file format will have. Okay. We'll look at the Parquet structure. Let me see if I have that. No. Oh. Sorry guys, I opened it, but I think, yeah. So here if you see, This is the Parquet data organization, which means how Parquet stores the data. Okay, like we discussed before, it is a hybrid combination of row groups and column chunks. So what it is going to do is, it is going to create a row group with limited size, and then it is going to start storing the chunks of columns. Chunks means if in a particular column we have 10 rows, in the first chunk, it is going to store 3 rows. In the next row group 1, it is going to store column A, chunk 1, which will have another 3 rows. Okay, so if you have to store 10 rows, you need 3 row groups, and within 3 row groups, you will have 3 different column chunks for that single column. Okay, this is just an example. It is not, um, this is just an example. Okay, so that's how it is going to store data in row groups and column chunks. So within each column chunk, there is going to be something called page. Okay, so this page is going to store the row level information. This is just a theory, guys. You need not remember all of this. This happens internally. Okay, this is just to tell you how Parquet is better than other formats. This is only theory and not even needed. For when you practice, you will not even look at all of this internal information. You will continuously optimize it. Okay, don't worry about these terms. These are just for your information. So this is going to have a page. Within each page, it is going to store the page metadata. What is page metadata? Metadata means the minimum value, the maximum value, the number of rows. If you see here, it is mentioned, right? Min, max, count. So this is what it is going to store. How this is going to help Parquet is, when you have the metadata, Parquet first reads the metadata, guys. It will not read the data. It will just read this metadata to identify whether I should read this page or not. If the metadata contains the minimum maximum values that are used by the user, then only it is going to read this page. Otherwise, it will skip this page and it will move to the next page. Similarly, for each column chunk, it is going to read the page metadata and see if it is needed to write the page or not. What this is going to do, it is going to reduce the performance overhead, right? You are continuously skipping the pages, you are skipping the columns, even you are skipping row groups. Why? Because the row group metadata is stored in the footer here, if you see. Okay, so Parquet file is going to have row groups and a footer within the file. Within each row group, you are going to have column chunks. Within each column chunk, you have pages. This is the structure of the Parquet file, right? So the advantage of Parquet file is, first, when you try to read data, immediately it will open this footer. Okay, it will open the footer and it will start looking at row group and column metadata. Okay, which means it will look at minimum maximum value of the row groups and column metadata. Okay, and then it is going to understand which row group should be read, which column chunk should be read, which pages should be read, and accordingly it will process and it will give you the result. Okay, you may think that this is a big process, it will take so much of time to identify row groups, column chunks, and pages. It is not going to be that case, because it is super fast. We will see it in action when we work with Databricks, but this is super fast. And the advantage is that you need not provide any schema. Okay, Parquet itself will create the schema when you are trying to write the data to this file. That is the another advantage, and we will see why it will help us if Parquet is creating a schema by itself. Okay, that is biggest advantage, and we will see it in future sessions. Let me give you a quick glimpse of um, how Parquet is going to store the data, guys. So let's say we have written a query that select uh, let's take ABC from a table where X is less than 5. Okay, this is our query. We are trying to query the column ABC from a table. Okay, and if you look at the table, um, you have ABC and X. It's 1, 2, 3, 4, 5. 7, 8, 9. Okay, ABC for now you assume there is something else in this ABC column. I am not trying it. I'm not writing it. So what happens within Parquet file is it is going to create row group 0, and within row group 0 it is going to create minimum value for X. What is the minimum value? Let's say it is 1, and maximum value, let's say it is 3. Okay, I'm just assuming here, there is nothing uh, a real case scenario. Here row group 1, it is minimum 4 and maximum 6. Okay, it is writing 3 rows. That's what I am assuming here. And it is decided internally by Parquet only, guys. We will not do it. So that's why we are assuming here. Okay, so this is how it is going to define the row groups. So what happens is, this is for X column, guys. I forgot to mention. And similarly, you will have uh, metadata about each column. Okay. If you have another Y column here, again, you will have metadata here for Y column. Like this, min, max. All right. Okay. So if you look at this, what it will do is, when you are trying to access X is less than 5, first it will look at this where clause. Okay. And what it will do is it will immediately go to row group. All of this information is stored in footer. Okay. If you remember, we talked about footer in the structure. So this information is stored in footer. So it will immediately go to the footer of the file and it will try to see row group 0 metadata. It says minimum 1, maximum 3. Because it is less than 5, this block may contain our required values. So this is going to highlight. Okay, yes, we need this block. We need this row group. Similarly, in row group 1, if you see minimum is 4, maximum is 6. This may also contain values less than 5. So this is going to be required. It will read this row group. Here, if you see row group 2, minimum is 7, maximum is 9, because we are looking at only less than 5. This may not contain our expected block. So it is going to just ignore this block. Block as in ignore this row group completely. Similarly, it is going to skip many row groups, guys. We discussed in columnar format, right? It is going to skip so many row groups. It is going to skip so many row groups and it is going to read only these 2 row groups. Okay, because our filter is on X column. It will read this X column metadata and it will just go to these row groups and it will get the data for 1, 2, 3, 4, 5. Okay, any questions on this? This is just important to understand in terms of performance improvements. So how Parquet is going to improve the performance of read heavy operations. So if you are trying to read so much of information, how is Parquet helping you? If somebody asks you, this is one of the examples that we can tell them, that it is going to read the metadata and it is going to identify which row group should be read based on the filter. Okay. This concept is called as predicate pushdown. Okay. Remember this term. It is going to be used so much when we move ahead in the course. Predicate pushdown means whatever where clause, whatever condition you are specifying in your queries, this will be considered as a first step. Okay. This will be considered. It is going to apply the filters first. Let's say your query is big tomorrow. Of course, we are going to touch base on SQL also, but for now you have some join conditions. Okay, on table.x equal to table2.x. Then you have where condition, where table.x is less than 5. Okay, let's say you have 2 tables. You are trying to merge 2 tables and you are trying to filter only table.x is less than 5. In SQL, what happens is the join operation is performed first in general. Okay, if you don't specify anything, it is going to pick the join condition first. First, it is looking from and then join. Now, what this predicate pushdown will do is it is going to do it like this. Okay. So this is going to push this filter, where clause filter in the first step. First, it is going to filter the records, and then it is going to do a join. Okay, we'll see this in action. For now, just remember that filtering is the first priority for Parquet. Wherever it sees filters, it is going to use those filters as the first step, because that is going to skip so much of information that we don't need, right? So predicate push down is one of the optimized approaches of Parquet. Okay, guys. Any questions?
No.
Yeah, so this is going to be the biggest advantage of Parquet. And the other advantage of Parquet, this is the last item. So the other advantage of Parquet is its encoding schemes. So what it is going to do is, when it is going to write the data in column chunks, right? It is going to group the data. Okay, so let's say if you see this data here, let's say you have United States, Netherlands, you see United States in twice. Okay, let's say you have a country column. In the country column, you will have duplicates, right? You have United States twice, you have Netherlands thrice, right? You have France twice. What Parquet will do is, let's also write down this in Excel. Okay. So let's say you have country column and you have USA, you have India, USA, and Netherlands. This is possible. Okay. Let's say you have name, Pawan, Ramesh, Sudesh, Ashok, and Raghu. Okay, these guys belong to these country. This is the data. So what Parquet does is, when it is writing this information to the file, because it identified that there are duplicates in country, whenever it is trying to write the country column, it is going to create groups, guys. USA group, and it is going to give it an integer. Okay, India, it is going to give an integer. Netherlands, it is going to give an integer, unique integer to this. Okay, that's what you are seeing here. Okay, it is going to create a dictionary with unique IDs given to each of the country. Okay, then what it is going to do is, it is going to change this data as USA, right? USA will be 1, comma 1, because USA is stored twice in this file. Okay, India is 2, comma 2. Netherlands is 3. Okay, that's how this is going to optimize the data storage further. Okay, don't worry about how this Pawan will be fetched when it is USA, Ashok will be fetched when it is USA. It is internally taken care by Parquet. But what I'm trying to highlight here is, whenever you have a column with duplicate values, it is going to convert it into numbers like 1, 2, 3, as you are seeing here, and it is going to store those numbers, guys. Instead of storing the entire United States of America, it is easy if you store only 1, because this takes less space, right? Storing an integer is always going to take less space than storing the strings, right? So similarly, for each and every column, it is going to look, let's say here you have another Pawan. So it is going to again assign an integer, and then it is going to compress it. This is how your 100 GB file is going to become 25 GB. Okay. So you can explain this in case if anybody asks you, but this is called as runtime, run length encoding. Okay, this is a beautiful concept of Parquet. So what it does is, it is going to identify duplicates, and it is going to store them like this. It is going to give an integer. This is a dictionary, guys. And then it is going to give this. Okay, so this is how Parquet is going to reduce the file size, and this is how it is helping the predicate push down. These are the two biggest advantages of Parquet and why it is used in industry. Okay, that's what you are seeing here. If you see, it is going to store it like this. See, 3, comma 3, you see here. So that is how it is going to come. I mean, I have not explained it in detail because it will be overwhelming for you to understand it in detail. But just assume that if there are duplicates, then it is going to assign a unique integer and then it is going to store it in commas like you see here. Okay, cool. This is the advantage of Parquet. So tomorrow, I mean in our next class, we are going to touch base on some of the important concepts of data fundamentals. We are done with the data engineering fundamentals today. Um, because of time constraints, I think I talked about discussing the source formats. I'll try to cover it in our next class, and then we'll kick off with our database, data warehouses, data lakes, and data lake houses. Okay, in our next session, we'll touch base all those four concepts in detail. We'll see which one is better, which one should be used against which formats, and which is the current industry supported formats. And then we'll proceed with Azure fundamentals, guys. Okay, feel free to post any questions you may have. There is one screenshot that I wanted to showcase to you. You see this? If you see, if you have a CSV or any text file of 585 GB, if you use ORC, it is coming at 131 GB, guys. See, it is making 78% smaller. Is this an advantage or not? Because you have 585 GB data, but when you read it in ORC, it is becoming 131. Why? Because it has some compression techniques, internal compression techniques that will reduce the storage of information. Okay. Next best is Parquet. Parquet is going to make it 221 GB. Okay. But the advantage of doing it in Parquet is supported in in so many formats, in so many systems. ORC is not having that much support. It is predominantly supported in Hadoop and Hadoop based Hive systems, but Parquet is widely supported. That is the biggest advantage. And also Parquet has some more additional advantages like predicate pushdown, like we discussed, run length encoding, right? So those are the advantages. That's why even though it is ORC is best in compression, we're still gonna use with Parquet. See, it is almost reduced to half.
What is run length encoding?
Yes,
Yeah.
we just this is the run length encoding. This
Yeah.
entire
Yeah,
approach.
I got it. Yeah, thank you.
Yeah. So that's the reason we go with Parquet. So see, the almost reading of data is reduced by half. So this is going to save a lot of time, and this is why people prefer Parquet over any other formats in the industry as of today. However, Parquet is not the best format, guys. There are few more formats which we are going to face in our future sessions, like Delta Lake, Apache Iceberg. It's good if you could go through it, but otherwise we have a session on that. Then we will discuss what are the disadvantages of Parquet, why we are moving to Delta Lake and Iceberg. What are the advantages, all of that in our future classes. Okay. So let me stop the screen share and let me stop the recording.